This video describes the steps required to complete a detailed inspection of switches for flange climb derailment hazards. The detailed inspection requires both visual and physical checks to be completed to determine the condition of the switch and stock rails of each half set of switches within the switch panel. To complete all the checks, switches will need to be swung from open and closed positions. The sequence of checks detailed in this video limits the number of times the switches are required to be swung to once during the inspection. Stand at the toe of the switch, looking down to the switch heel. This determines the left and right-hand side of the switch. These switch positions are used on the TEF form. It is important for the detailed inspection to be completed in full before determining which remedial actions are required. However, emergency mitigating action should be implemented as soon as any severe defects are identified. To complete this inspection, you will need TEF 3029 form, NR4 plain rail side wear gauge, a metric step gauge, TGP8 track gauge, a feeler gauge of 200 micron thickness, switch wear gauge, known as gauge 1 and gauge 2, tape measure, switch rail radius gauge, a scraper and/or wire brush to remove grease and dirt, and approved lubricant. Complete site information on TEF 3029. Record gauge numbers for all tools used during the inspection. Before starting the inspection and recording any measurements, use a scraper or wire brush to remove enough grease and accumulated residue to assess the switch for lipping, switch blade damage and wear. On the closed half set, use the step gauge to measure the seating gap between the underside of the switch blade and base plate. Take this reading at the slide base plates from the toe toward the heel. This gap is also known as hogging. Record all measurements within the appropriate sections of TEF 3029. Inspect the closed switch. Visually check for any signs of damage throughout the machined length, damage that spans 200 mm or greater, damage at more than one location. Visually check for the presence of any sharp corner or faceted edge along the running edge of the switch rail throughout the machined length. Check for signs of flange climb throughout the machined length. Observe the position of the top of the switch rail in relation to the stock rail sidewear scar. Is the switch rail level with or projecting above the stock rail sidewear scar within the first 2000 mm from the switch toe? Is the switch rail 2 mm below the stock rail sidewear scar for 2000 mm from the switch toe? Check for any signs of the switch tip being struck or damaged. Inspect the open switch. Check for any horizontal or vertical cracking on both the rear face and running edge of the switch rail. Check for lipping on both the rear face and running edge of the switch rail and associated stock rail. All damage details, including position, need to be clearly recorded in the visual inspection section of TEF 3029. Inspect the open switch. Using the NR4 gauge, measure sidewear at the toe, 500 mm and 1000 mm in front of the switch toe. Any areas of concern should be investigated further by taking more measurements within that area. If any sidewear is present, record the worst reading on TEF 3029. Next, check for sidewear to the stock rail. This should be taken behind the switch toes, 500 mm and 2000 mm from the tip. Any areas of concern should be investigated further by taking more measurements within the area of concern. If any sidewear is present, record the worst reading on TEF 3029. Inspect the open switch. Using the switch rail radius, check the running edge radius of the open switch rail along the running edge throughout the machined length. The gauge should be placed on the machined face at a maximum of 100 mm increments for 1000 mm from the toe or 2000 mm for RT60 and NR60 switches. Care should be taken to confirm that face A of the gauge is in contact with the machined face of the switch rail as illustrated. Pass condition. The gauge should be in contact with the switch rail at face A and face B. This allows a gap to be present between face C of the gauge and the switch rail. There should be no visual or tactile evidence of a sharp running edge radius. Fail condition. The gauge is only in contact with the switch rail at face A, as a sharp running edge is in contact with the gauge at face C, preventing the top of the switch rail contacting with face B of the gauge. When the switch blade is too thin to contact the gauge at face B, then to pass this check, it must be confirmed that face A of the gauge is fitted flush to the running edge of the switch rail. The top of the switch rail must make contact with the gauge throughout section at A. Note, the top of the switch rail must also be in contact with a proportion of face C. Ensure there is no visible or tactile evidence of a sharp running edge radius. Record the worst reading on TEF 3029. Inspect the closed switch. Using a TG-P8 track gauge, check throughout the switch for contact between the P8 wheel profile and switch rail. TG-P8 gauges have a 60-degree line marked on the P8 profile, as well as two additional lines, 2 mm above and 2 mm below the 60-degree line, illustrating the 65-degree and 55-degree contact angles. The gauge must be used with switch closed and any seating gap compensated for using the metric step gauge. Place the metric stepped gauge on the crown of the stock rail. Place the P8 profile on the metric stepped gauge at the measured seating gap or on the crown of the stock rail if no seating gap is recorded. Push the TG-P8 gauge firmly against the switch so that the P8 wheel profile of the gauge makes contact with the switch rail. If two profiles are present on one side of the gauge, make sure both contact the switch rail before taking any measurements. Then, using the feeler gauge, check the location of the flange contact on the P8 profile. Repeat this process at regular 100 mm increments for 3000 mm from the toe or 6000 mm for RT60 and NR60 switches. Any areas of concern should be investigated further by taking more measurements within that area at intervals of less than 50 mm. Record the P8 profile readings in the relevant section of TEF 3029. Where the contact angle is below 55 degrees for a distance of 50 mm or more, immediately ban all facing traffic movement until switch repair work has been carried out or the half set of switches is replaced. If the gauge measures between 55 degrees and 60 degrees for a distance of 200 mm or more, apply lubricant immediately and repair the switch blade within 36 hours. Alternatively, ban all facing traffic until switch repair work has been carried out, or the half set of switches is replaced. If the switch blade contact angle is between 60 degrees and 65 degrees for a distance of 200 mm or more, plan to grind or weld repair the switch to a minimum angle of 65 degrees within 13 weeks. If the contact angle is above 65 degrees, no further action is required. Gauge 1 check on the closed switch. Note, a check with gauge 1 does not apply to straight cut switches due to the design of the switch tip. Pass gauge 1 over the first 40 mm of the closed switch from the switch tip to check for stock rail headwear. If a seating gap has been identified, place the metric stepped gauge on the crown of the stock rail. Place the long edge of gauge 1 on the metric stepped gauge at the measured seating gap or place gauge 1 directly on the crown of the stock rail if there is no seating gap. Ensure the lower square edge of gauge 1 contacts either the switch or stock rail. Check whether gauge 1 passes over the tip of the switch rail throughout the first 40 mm of the switch. A fail condition is when gauge 1 makes contact with the switch rail. Record the location of any contact with the switch rail on TEF 3029. Gauge 2 check on the closed switch. Gauge 2 is used throughout the reduced head section of the switch from the toe to the heel to check the relative height between the stock rail head and the top of the switch blade. Pass gauge 2 over the closed switch throughout the machined length, accounting for any seating gap at each bearer position. If a seating gap has been found, place the metric stepped gauge on the crown of the stock rail. Place the long edge of gauge 2 on the metric stepped gauge at the measured seating gap, or directly on the crown of the stock rail if there is no seating gap. Ensure the lower square edge of gauge 2 contacts either the switch or stock rail. Check whether gauge 2 passes over the switch rail throughout the machined length of the switch. A fail condition is when gauge 2 passes over the switch rail. In this situation, undertake the following checks. Is the switch rail damaged at this point? Are there any signs of flange climb? Are there any signs of flange contact? Record any details, including the position along the switch, on TEF 3029. Ask the signaller to swing the switch and repeat all previous actions for the opposite half set. Following completion of all checks detailed on TEF 3029 for both half sets, ensure all information has been entered onto the form. Apply a sufficient amount of approved lubricant along the switch, paying attention to the diverging root rail. With the inspection complete, review TEF 3029, identifying defects present, and take the required actions, as detailed in the action tables in accordance with NR L2 TRK 0053. By the end of the shift, return TEF 3029 to the relevant section manager.